As the digital world begins to move past Web 2 technologies, blockchain has emerged as a transformative force that promises to reshape the way we interact with each other and the internet. However, there are many scalability issues faced by numerous networks. Even Ethereum, one of the largest of the blockchains by market cap, has had hindered adoption and growth. Is there some magical technology to roll in, pardon the pun, and save the day? Yes, there is. Let me introduce to you ZK-proof technology. You do not want to sleep on this. Life or deep dive? Let's go. ZK rollups and ZK EVMs, short for Ethereum virtual machines, are new technology that uses zero-knowledge proofs to enable faster, cheaper, and more private transactions on blockchain networks. By bundling multiple transactions into a single proof that is submitted to the blockchain, ZK rollups significantly reduce the amount of the data that's needed to be stored on blockchain, making it faster and more efficient. The technology has the potential to revolutionize blockchain by enabling the development of more complex and sophisticated decentralized applications that were not possible before. With the scalability and cost benefits of ZK rollups, developers can build applications with high throughput and low latency, such as decentralized exchanges, games, and financial applications. In this video, we will explore the world of zero-knowledge proofs, ZK rollups, and ZK EVMs, what the technology is, and how it can help blockchain networks like Ethereum scale to meet the demands of a growing user base. We'll also examine the challenges that come with implementing ZK, along with some projects to look out for with potential to revolutionize crypto using the ZK technology. Join me on this journey as we explore the world of zero knowledge and this exciting new branch of blockchain technology. So what is zero knowledge, or ZK? ZK rollups, based on zero-knowledge proofs, is a technology with bold claims, supposedly faster and more secure simultaneously. Normally, in the digital world, a trade-off is involved here. You can either be faster or you can be more secure. So how does this technology work? It sounds like magic. Let's dive into it. Let's start with the name, ZK rollup. The ZK stands for zero-knowledge proofs, and rollups refer to them being multiple transactions rolled up together into a single contract. Zero-knowledge proofs are fascinating concepts in the world of cryptography that enable the verification of information without revealing any sensitive data. In a zero-knowledge proof, one party, known as the prover, wants to convince the other party, known as the verifier, that they have the knowledge of a certain piece of information without revealing the information itself. Have I lost you yet? The basic idea behind zero-knowledge proof is that the prover can provide a piece of evidence that proves they have knowledge of the information without actually revealing the information itself. The verifier can then use this evidence to verify the claim without ever seeing the underlying information. Yes, this is definitely magic. This sorcery is achieved through a complex mathematical process that involves creating a proof that the information in question satisfies a certain condition, while keeping the information itself hidden. This proof can then be verified by the verifier, who can be sure that the information is true without ever actually seeing it. What this all boils down to is ZK rollups enable both security and privacy by default as part of their process, without slowing down the transaction speed of the blockchain itself and requiring complicated extra software layers for security. Let's have a look at how ZK rollups will be implemented to scale Ethereum and make your transactions safer, faster, and more private. ZK rollups rely on two smart contracts, the main contract and the verifier contract. Both run on Ethereum and work in tandem to link Ethereum with Layer 2 blockchains. The main smart contract stores roll-up transactions. It also compares the blockchain state to determine the state of users' withdrawals and new deposits. The verifier contract authenticates these transactions in a block with zero-knowledge proof technology, working off-chain, not on a blockchain. A virtual machine runs the ZK rollup. This offloading, which involves computational power not suited for running on the blockchain, allows ZK rollups to execute fast transactions so that the Ethereum blockchain itself is left uncongested. Just like an Ethereum virtual machine, or EVM, a ZK virtual machine is a software that runs smart contracts. With this virtual machine, ZK rollups batch Ethereum transactions off-chain into a single batch transaction, adding efficiency and scalability. Nevertheless, they still rely on Ethereum blockchain as they submit the transactions as validity proof back to the Layer 1 network. While similar and often both labeled as ZK rollup, one key difference between ZK rollups and ZK EVMs is that a ZK rollup is focused on scalability, while ZK-EVM is focused on privacy. A ZK rollup allows for a large number of transactions to be processed off-chain while still maintaining the security and integrity of the Ethereum main chain. On the other hand, ZK-EVM allows for the execution of smart contracts in a privacy-preserving manner, allowing for the creation of private, confidential transactions on the Ethereum platform. Both ZK rollups and ZK-EVM are significant innovations that can help improve the scalability and privacy of Ethereum. They both have the potential to significantly enhance the capabilities of the Ethereum platform and make it more useful for a wide range of applications. As with all new technology, just as we have seen with crypto itself, there will always be hurdles to overcome. Whether psychological barriers or just change in compatibility and technical challenges, the adoption of zero proof will not be without hurdles. Let's have a look at the potential problems facing this new tech. One of the primary challenges with ZK rollups is their complexity. The technology relies on sophisticated cryptographic algorithms to prove the validity of the transactions without revealing any confidential information. This requires a deep understanding of advanced cryptography, which can be a significant barrier to enter for developers. The more complex the cryptographic algorithms used, the greater the risk of bugs and vulnerabilities introduced by inexperienced developers. Another significant change with ZK rollups is their limited capacity. Although rollups can process thousands of transactions per second, there is still a limit to how many transactions can be bunched into a single rollup. This means that as the number of users and transactions on the blockchain network grows, the number of rollups needed to accommodate them will also increase, adding to the complexity and the cost of the system. As many layer 2s are learning, there is no infinitely scalable solution. Furthermore, ZK rollups face challenges related to interoperability because each rollup is a separate layer on top of the underlying blockchain. There is a risk of fragmentation if different rollups are not able to communicate with each other. This can limit the usefulness of rollups as a scaling solution, as it may not be possible to transfer assets between different rollups or integrate rollups without applications. Another challenge with ZK rollups is the issue of data availability. Because of the actual transactions are aggregated into a single rollup, the underlying blockchain may not have access to all the data it needs to validate the transactions. This can create potential security risks, as the validity of the transactions cannot be fully verified. To address this issue, some rollup implementations rely on a trusted party to provide the data, which can also be a central point of failure. Finally, ZK technologies face regulatory challenges related to privacy and compliance. Because ZK proofs use sophisticated cryptographic algorithms to obscure the details of transactions, it can be difficult to determine the source and destination of the funds, which can complicate compliance from anti-money laundering and know your customer regulations. While ZK rollups are designed to maintain user privacy, regulators may view this as a potential risk and may require additional transparency and oversight. Tornado Cash, anybody? So who are the digital pioneers leading the way with ZK rollups and ZK EVMs? Let's have a look at some of the biggest names pioneering this technology. Everyone knows about Polygon, or known as Matic. It rose to the forefront of Ethereum Layer 2s in 2022, but the chain is also forging ahead in the employment of ZK rollups. The importance of Polygon ZK rollups has been gaining attention in the cryptosphere after the launch of Polygon Zero Knowledge Ethereum Virtual Machine, or ZK EVM. Polygon is one of the top Web3 infrastructures with some of the biggest companies in the world, such as Reddit, Meta, and Stripe on board. Polygon launched the Polygon ZK EVM in July of 2022 as the first scaling solution with features similar to Ethereum, such as support for developers, tools, wallets, and existing smart contracts. Think of Polygon ZK EVM as an equivalent of the Ethereum network, but with better security through zero-knowledge proofs. Polygon has come up with many ZK rollup implementations in its product suites, such as Polygon Zero, Polygon Maiden, and Polygon Hermes, which uses its own Hermes ZK EVM implementation. While Matic has been the biggest player, ZK Sync is another one coming up behind. ZK Sync is another ZK rollup-based Layer 2 scaling solution that offers cheaper and faster transactions than the main Ethereum blockchain. ZK Sync has been developed by Matter Labs. They have received funding from both the Ethereum Foundation and top-tier investors, such as Union Square Ventures. While dApps will be able to build on ZK Sync, the platform isn't ready yet. It will also be EVM compatible, meaning developers will be able to take existing Ethereum smart contracts and easily transfer them to the ZK Sync Layer 2. This will help when ZK Sync 1.0 Lite transitions to ZK Sync 2.0 ERA, which is expected to happen in the early to mid-2023. Unlike other EVM-compatible ZK rollups, such as Polygon, ZK Sync supports account abstraction. Account abstraction turns every account into a smart contract with its own logic. This is huge because it enables everyone to have an account adapted to their needs, increasing compatibility, configurability, and security. Then we have StarkNet by Starkware. This is another ZK rollup scaling solution, but unlike the other ZK rollups like ZK Sync, StarkNet isn't a ZK EVM, meaning smart contracts have to be written in the StarkNet's own programming language called Cairo. StarkNet uses Starks, which is the same name it gives to its own version of zero-knowledge rollups. Cairo is a custom programming language optimized for ZK rollups. It allows you to do everything you can do on EVM and much more, as computations are significantly cheaper and therefore faster and more scalable. This creates new possibilities that previously weren't possible on blockchains, such as true on blockchain games and AI deep learning running on-chain. StarkNet has already been integrated with several popular blockchains including Ethereum, Binance Smart Chain, and Polkadot. This allows developers to build DeFi applications, for example, DYDX, on top of these platforms using StarkNet without worrying about scalability and compatibility issues. In addition to DeFi, StarkNet is also being used in various other applications, including a supply chain management, voting systems, and even medical research. These three names are just the tip of the iceberg when it comes to ZK-focused crypto companies. There are so many more top projects pushing this new field, such as Scroll, Mina, Immutable X, and many, many more. Keep your eyes peeled for this narrative in the future. Oftentimes, I find a narrative like this, and with some due diligence, I'm able to discover some key winners that can 10, 50, or even 100x. As we come into the end of our exploration of ZK rollups and ZK EVMs, we stand at the cusp of an exciting new era for blockchain technology. These cutting-edge solutions have the potential to revolutionize the industry, unlocking new levels of scalability and efficiency that were previously thought impossible. Looking to the future, it is clear that ZK-proof technology is poised to play a key role in driving the next wave of innovation and progress in the blockchain space. As these technologies continue to be refined and developed, we can expect to see an explosion of new use cases, applications, and services that leverage the scalability, privacy, and security. From decentralized finance to supply chain management, ZK rollups and ZK EVMs have the potential to transform countless industries, unlocking new levels of efficiency, transparency, and security along the way. It is yet another force pushing crypto and blockchain technology into the mainstream. As we embrace this new frontier, it's an exciting time to be in crypto, and I can't wait to see what the future holds.